All right, this is the section that I usually can take a big, deep breath on. We've gotten through the hardest part of the class, all those different bases. So now let's look at what most people feel much more comfortable with, adding whole numbers. We're going to get into some actual ideas that we would use in the classroom that we could, and we actually use these other bases in classrooms. I've talked about that, but what people think about when they think about teaching math to students in our primary and elementary grades. So whole numbers, we actually started using this in the last section, but I didn't introduce them. Whole numbers start with 0 and continue on to infinity. No decimals, fractions, no negatives, none of that stuff. The difference between what we have been doing in this is the number 0. So our natural numbers started with 1 and kept going on through infinity. And we whole numbers are all those natural numbers plus the number 0. 0 is a pretty important number. There are number systems in the world that don't use 0. So they do exist. We can think about the Roman numerals. That's one that a lot of times people think about using, where you've got like the X meaning 10 and the X before meaning 9, the with the 1, and then X with a 1 meaning 11. So that does not use 0 placeholder in their system. So this is a big deal when systems do have zeros. That's why it gets this whole extra name of whole numbers. Addition is the union. When we think about like unions and intersections and set difference, addition is our union. So we're combining things together. And of course, we start this pretty early on. You might see it even in a pre-K class, pre-K4 class, but definitely in like a kindergarten class. So this first section is going to be introducing methods of how we would introduce a problem. So maybe I might have a problem that looks like this. We know that means adding, but we would have to teach our students that 5, that little t means plus 3. They're not going to know that's plus 3. We have to teach them that we read that as 5 plus 3, and we have to teach them that that means to combine together all of the 5 and all of the 3. We would start with things that they would already kind of understand, like someone has 5 pencils and they go to the store and buy 3 more. How many pencils do they have? We could tell them that this sentence, right, this number expression, I should say the number expression that I have here, now we've got a number sentence, would be equivalent to the story I just told. So one way we could do it is I'll start with this set model down here. Now I can't draw very well. I'm just do a little fish here. So I'll keep with my 5 plus 3. 1, 2, 3, 4, 5. Plus 3, and I can show visually what this means to do is we put all the little fish together. That plus there means that we're going to combine them together. It would be all the fish. These two numbers, the 5 and 3, are called the addends, and the answer is called the sum. All right, we also can have a number line model. Number lines are super, super helpful. We're going to see number lines used throughout the course. The good thing about number lines is you can trick students, not really trick them, but you can make adding a little bit more fun with number lines, because there's really easy to make games with number lines, moving different objects up and down a number line, or even like thinking about chutes and ladders, or having to add how many spaces you go. So there are lots of games out there that exist. You can buy lots of math games that make students move up and around number lines. And so they think they're having fun, which they probably are having fun, but we're kind of sneaking in there that they're having to do some math while they're having that fun. So a number line model, I'll just stick with my 5 plus 3. I'm going to start at 5, and I would make 1, 2, 3 jumps to end up at 8. It is important on a number line model to somehow mark where we're going to start and the direction that we're going to go in. You could put an arrow, you could put that plus 3, you could put an arrow up here at the top. We're going to see when we get into subtraction that we're going to the left. Eventually we'll be subtracting negative numbers and adding negative numbers, so those directions become really important. So when you go to turn work in, for me, if you turn it in online, then you're going to have whatever problem you're working, you might have to draw out a number line. To get full credit, I have to know what you're thinking. I can't be in your head, so you have to write that stuff on the paper. So the work you show is really important. I know we all know the answer to this problem is 8. That's not a big deal. Like, I know you can add. 5 plus 3 is 8. I need you to communicate that to me in a way that I believe that you could communicate it to a student later on. Now I'm going to go back up to this idea of counting on. And this is something we would like students to be able to do like at the end of kindergarten and the beginning of first grade. So with this, I'll just stick with this 5 plus 3 problem. If we can go the set model, number line model, we don't want students to go 1, 2, 3, 4, 5, 6, 7, 8. That's the correct way to do it. We can get the answer 8, but we want them to get more fluent, faster. So instead of starting at 1, we want them to start at the number 5 and say 5 and then start counting with like their fingers or manipulative or something. 6, 7, 8. So we can see those 3 numbers there. It just makes it a lot quicker. And fluency is a big part of mathematics. You probably remember having to take those time tests where you see how many you can answer in a minute, or you might have like 50 of them you have to do in 5 minutes, because we want to get up our fluency, our speed on some of these operations.